Hello, I am Diego Cherres. It is an honor to be in the 15th Congreso Internacional Multidisciplinario de Ciencia y Tecnología. I am going to talk about the addition of sawdust and polystyrene in the elaboration of Adobe blocks for single-family homes and its effect on temperature variation and acoustic conditioning in Ambato, Tungurahua. The idea to work with Adobe came to my mind when I was studying my master's degree in Universidad de las Fuerzas Armadas, ESPE. About 3 years ago, I visited Mexico with my research group, and we saw that people still work with Adobe. With this research, we try to help our planet by starting from our country, Ecuador. In Ecuador, waste generation in 2014 was 4.18 million metric tons, according to the National Program for the Integral Management of Solid Waste. According to the Ministry of the Environment of Ecuador, MAE, the main solid wastes are organic, cardboard, paper, and plastic. For this reason, it decided to include wastes such as sawdust and EPS to the elaboration of Adobe blocks as additives to improve the characteristics of mechanical, thermal, and acoustic resistance for the use of single-family homes. Here, from A to C, are the materials that were used in the manufacture of Adobe blocks. A. Land, a non-standardized construction material. Its properties vary depending on the production sites, but its composition may include different percentages of clay, silt, fine sand, coarse sand, and organic matter in some cases. B. Sawdust, organic material composed of cellulose fibers with small and fine particles smaller than 6 millimeters, obtained through mechanical processes of wood processing, with a composition of 50% carbon, 42% oxygen, 6% hydrogen, and 2% nitrogen. C. Expanded polystyrene, EPS, form of cellular plastic material, derived from natural gas and oil. Chemically contains 95% polystyrene and 5% gas, reducing the density of the material. It has acoustic, electrical, and mechanical insulating properties. With the Adobe blocks, its resistance was verified with compressive strength test. For temperature variation and acoustic conditioning, Adobe block walls were built to be used inside a test chamber. With the blue equipment, the Spark LXI data logger, and a temperature, sound, and lighting sensor. Here is a detail of the samples. For the thermal and acoustic tests, a total of 72 samples were used with the percentage of additions shown in the table below, specifically in the second column here. 18 samples for each percentage. For the compressive strength tests, a total of 24 samples were used with the same percentages, 0, 5, 10, and 15. 6 samples for each percentage. The test chamber has two environments. On the left side are the heat source and the sound source. In the middle, the Adobe block walls. With different sensors are possible to identify what happens in the right side. In conclusion, the addition of Sawdust and EPS to a traditional Adobe block by 15% improves its resistance to compression in reference to the E0A0 standard with 12.14 kilograms per centimeter square. It allows a thermal comfort close to what the NEC 13 standard indicates, at this minimum value of 18 degrees Celsius, and a sound insulation level higher than the NCH 352 standard, with a value higher than the recommended value of 5.31 dBA. Therefore, the results of this study indicates that the traditional Adobe is improved by adding 15% of residues to the Adobe composition. This research also aims to motivate the implementation of recycled material, such as sawdust and polystyrene in single-family homes, with the sustainability concepts and energy savings, since the resistance to compression of each block exceeds the regulations. Likewise, it maintains good insulation, thermal, and acoustic comfort. Thank you. Thank you all.